Okay, so what I want to do now is I want to go over the review, some selected problems from the review. Just kind of give you a little review of how we do mole problems, percent composition, and empirical formulas. Okay, starting with number 1. Okay, so the problem says find the mass of water that is in 0.224 moles of H2O. So 0.224 moles of H2O. Now remember, anytime it says you want to find the mass, you have to go through the formula way. Anytime I see grams, I go through the formula way. So 1 mole of H2O has a mass of 18 grams of H2O. So I'm going to put that in the calculator, and I should get 4.032 grams of water. Okay. Number 2. It says I want to calculate the number of moles in 2.71 times 10 to the 22nd molecules of CO2. So I put my given over 1. Now, anytime I see molecules or atoms, I'm going to go through Avogadro's number. So Avogadro's number is 6.02 times 10 to the 23rd. And since CO2 is more than one element, it's going to be a molecule. And that's equal to 1 mole of CO2. Okay, we put that in the calculator. Now remember, if you have some of those special calculators that we talked about in class, where you have to put parentheses around Avogadro's number when you divide, you need to make sure you do that. So I got 0.045 moles of CO2. Okay, number 3. It says calculate the formula weight of ammonium dichromate. So we know from our ion chart, ammonium is NH4 and it has a +1 charge. Dichromate is Cr2O7 with a -2 charge. So I'm going to crisscross. So I'm going to take this, the 1, and I'm going to bring it over here. And I'm going to take the 2 and bring it over here. So when we crisscross a number to a polyatomic ion, we have to use parentheses. So Cr2O7 does not have parentheses around it, okay? Now, when we go to do the formula weight, we count 2 times, so there's going to be 2 nitrogens at 14 each. I have 8 hydrogens at 1 each. CR, I have 2 CRs at 52 each. And I have 7 oxygens. And 7 times 16 gives you 112. Now we add all those numbers down and we get 252. And that's all it's asking for whenever you find the formula weight. Okay, number 4. So number 4, it says how many atoms of oxygen are there in 150 grams of Fe2O3? So 150 grams of Fe2O3. So anytime I see grams, I go through the formula weight. Now the formula weight of Fe2O3 should come out to be 160 because you got 2 times 56 plus 3 times 16 gives you 48. So you add them together and you get 160 grams of Fe2O3 to 1 mole. Now, anytime I want to go to molecules or atoms, I have to go through Avogadro's number. So 1 mole of Fe2O3 is 6.02 times 10 to the 23rd molecules of Fe2O3. Now it's molecules because there's more than one element in it. Okay, and then the last step we're going to do is we're going to take and we're going to look how many atoms of oxygen do I have in one molecule. So in one molecule of Fe2O3, I have 3 atoms of O. Okay, and I'm going to put that all in the calculator. Let me just double check my answers real quick. 150 times 6.0223 times 3 divided by 160. And I got 1.69 times 10 to the 24th atoms of O. Now number 5. Let's look at number 5. Says, what are the number of atoms of nitrogen in 5 grams of dinitrogen tetraoxide? Okay, so dinitrogen is N2, tetraoxide is O4. Anytime I see grams, I have to go through the molecular weight. So nitrogen weighs 14, so 2 times 14 is 28, plus oxygen 4 times 16 is 64. So we get 92 is the molecular weight of N2O4. And that's equal to 1 mole of N2O4. Now, the question is asking how many atoms of nitrogen. Okay, so anytime I see atoms, I have to go through Avogadro's number. But this is a molecule because there's more than one element in it. Okay, and then we're going to do that extra step to get to atoms. So it's asking for atoms of nitrogen. So there's 2 atoms of nitrogen in that molecule. Now we're going to multiply all those numbers out. Sorry, I'm trying to adjust the camera just a little bit. So we're going to multiply all those numbers out. And we should get 6.54 times 10 to the 22nd atoms of nitrogen. Okay, number 6, I'm going to let you refer to the answer key for that to go through those for the sake of time. Number 7, I'm going to do part A. Okay, so it says I want to find the percent composition by mass of those 3 compounds, A, B, and C. They're all different compounds. So it's the same process for all 3 of them. So our compound is C3H4O2. Now when we do percent composition, we're going to do carbon. We have 3 carbons. Carbon weighs 12 at 36. Hydrogens. I have 4 hydrogens and each one weighs 1. Oxygens. I have 2 at 16, which is 32. We're going to add all those down. So 36 plus 4 plus 32 should come out to be 72. Now, it wants to know the percent composition of each element. So we're going to do percent C is going to be 36 over 72 times 100. We're going to do the percent hydrogen, which is 4 over 72 times 100. And we're going to do percent oxygen is 32 over 72 times 100. Okay, we're going to put those in our calculator. So 36 over 72 comes out to be 50%. 4 over 72 is 5.56%. And 32 over 72 is 44.44%. Okay. And let's see. Let's work an empirical formula 1. Let's see which one was a good one. Let's look at number 10. Okay. As I noted in the announcement that we're not going to be using chlorine because chlorine's almost a 0.5, so it's going to throw off your molecular weight a little bit. So number 10. Okay, so it says we have 26.7% P. So we're going to say 26.7 grams of P. P has a molecular weight of 31. Okay, and then we're going to say 12.1 grams of nitrogen over 1. And nitrogen has a mass of 14. And then it's 61.2% Cl. Now, this is where it gets a little bit tricky. So we're going to say that grams. Sorry, grams. Let's write grams here. We're going to use 35.4 grams of Cl. 35.4 will make our answer come out to be 580, so it's going to work a little bit better. Okay, so 1 mole of Cl. Now we're going to put these numbers in our calculator, so 26.7 divided by 31 is 0.8613 moles of P. And then we're going to do 12.1 divided by 14 is 0.8643 moles of N. And then chlorine, 61.2 divided by 35.4 is 1.7288 moles of Cl. Okay, so our second step was to divide through by the smallest number, 0.8613, 0.8613, and 0.8613. So for this reason, this is why we did the 35.4, so it would come out a little bit better. So we should get 1, 1, and 2, like that. Now, it gives us a molecular weight of 580, so our empirical formula is going to be PnCl2. Okay. Now, we have to check the mass of this. So once again, let's use our molecular weight of this. So phosphorus weighs 31, nitrogen weighs 14, and we're going to call chlorine 35.45, rounds pretty close to 35.5. So our molecular weight is going to come out to be 116. Okay. Now, to check our weight, we do 580 divided by 116 to see what we have to multiply by. And this comes out to be almost 5. Now, if you were to use chlorine as 35, you would have got 115, okay? And 580 divided by 115 is 5.04, which is really close to 5. So it's really not going to throw your answer off too much, okay? So we have to multiply everything through by 5. So our final answer in molecular formula is P5N5Cl10, okay? And hopefully this helps you a little bit on reviewing problems for your test. The test will probably have, I think, 6 to 7 regular mole problems. It'll have, I think, 4 or 5 empirical formula questions that are very similar to the worksheet that we did in class and the example problems. Make sure you look at the hydrate questions. Your molecular weight, there's a few molecular weight questions, and there's like 4 or 5% composition questions. From what I can remember about the test, there's, I think, 18 to 20 questions on it. Some of them, one of them I might have to omit because I just don't think it's going to work out with the online stuff. So if you have any questions, feel free to text me or email me, and hopefully you'll have a good night. Thanks.